Okay, in this video I want to do another example of a limit at infinity. So let's do this next example. It's to find the limit. So find the limit. And it's the limit as x goes to infinity of the square root of 81x squared plus x minus, so this is inside the square root, and then minus 9x. That whole thing. Okay, before I explain how to do it, I want to give some examples of wrong solutions. So here's one thing that's not correct. So what, and this is something that students often do, is they'll plug in infinity here so that they see, okay, x is going to infinity. And so they think, well, I just need to plug in infinity wherever I see an x. And the problem is, okay, so if you had, let's just see what happens if you did that. First of all, there's a problem with plugging in infinity because it's not even a number. So what does that even mean when you plug in infinity, right? But let's just say that you somehow could plug in infinity. Then what would you get? Well, you'd have an infinity squared plus 81 times infinity squared plus infinity, and then square root of that, and then minus 9 times infinity. Well, this part, actually, if you think about it, if you have a really large positive number and then you plug that in, you're going to get a really large positive number, and as the positive numbers get bigger and bigger and bigger, this quantity is going to get bigger and bigger and bigger. It's going to get more and more positive. So actually, this limit will be, this value can be thought of as infinity. And then you have a minus sign, and then 9 times infinity, you can think of that as infinity. And here's the problem. It's the infinity minus infinity. So this is undefined. That's undefined. Okay. Why is it undefined? So the reason has to do with the fact that if you have something that goes off to infinity and then subtract something that goes off to infinity, the difference can actually approach whatever number is possible. So for instance, you could have, so why is this undefined? So you can have something like x minus, say, x plus 1 or something. So this quantity x, that's going to infinity. X minus 1 is going to infinity. But what's x minus in parentheses x plus 1? That's going to be x minus 1. That's negative 1. And negative 1 is going to approach negative 1. Right? It's just negative 1. So it's undefined. I mean, the limit of this quantity, the limit of this will be negative 1. But the reason why infinity minus infinity is considered to be undefined is because you can adjust this example to give you any limit. You know, if you replace this 1 by a constant c, say, then the limit will be negative c. I mean, negative c can be anything. So, you know, when you have infinity minus infinity, I mean, it's not even so much, how do I put this? You know, this has to be given a meaning, right? I mean, infinity, if you just think of it as a symbol, infinity minus infinity, that's like 3 symbols next to each other. You have to decide what meaning to give it. So it doesn't a priori, you know, it doesn't already have a meaning by itself. And what mathematicians decided was that it's better to just not give this any meaning at all. So infinity minus infinity is just a meaningless expression. People decide not to give it any meaning. Okay. So this is actually something called an indeterminate form. when you get to the section on L'Hopital's rule, there's more examples of indeterminate forms. But basically, the bottom line is when you have some function and it's something minus something, and each of those terms is going to infinity, then you don't actually know what the limit's going to be, okay, by knowing that. So infinity minus infinity is not something that you can work with. So that's why it's incorrect. So some students will say this is 0, some students will say this is infinity. I mean, you can't tell what the limit of this is going to be. If you have infinity minus infinity, you have to do something else. Okay, let's look at another wrong approach. Now this step is actually, it's not so much the steps. So let's say that you do the thing where you pull out a power from the inside again, and this is something that we've done before. So let's rewrite this expression that we're trying to evaluate. This square root of 81x squared plus x, let's factor out an x squared from the square root. Well, if you do that, you're going to get x squared here, and then times 81 plus 1 over x, right? And then minus 9x. And then if you pull out the square root of x squared, that's, since x is positive, this is just going to be x, so you have x times the square root of 81 plus 1 over x minus 9x. Okay. And now I have an x here and an x here. I can factor out the x, so I'm going to get the limit as x goes to infinity of x times the square root of 81 plus 1 over x, okay, minus 9. Now we run into the second problem, because right now what I see is I have an x and then times this thing. Now let's look at each of these things as x goes to infinity. So as x goes to infinity, x is obviously going to infinity. Okay. Now what about this second term? So square root of 81 plus 1 over x. Well, 1 over x is going to 0. Right? This thing is going to 0. So then the square root of 81 plus that is going to go to the square root of 81. That's 9. Right? And now 9 minus 9, I have a minus 9 here. So I get 0, right? Because 9 minus 9 is 0. So the limit of this expression is 0. So this is approaching 0. And now we get something that has the form infinity times 0. And this is another example of an indeterminate form. So this is also undefined. Right? And so you run into the same, well, not the exact same issue, but it's a similar issue that you get something that's undefined, and you can't figure out what the limit is by this method. So it's not even so much that the algebra is wrong. I mean, the algebra is correct. It's just that this approach doesn't help you get the answer. Okay, why is this undefined? And again, this is something that you see more later when you learn about L'Hopital's rule. But the reason why this is undefined is, and again, this is a thing where mathematicians decided not to give this any meaning. Right? Okay, why do mathematicians decide not to give this any meaning? Well, because you can have something that's approaching infinity times something approaching 0, and then the limit can actually approach, the limit can be anything you want. So for instance, let's say that you had, okay, let's say that you had the limit as x goes to infinity of x times c over x. So c is some constant, right? Now x times c over x is just c. So the limit of this is c. But x, that's going to infinity. C over x is approaching 0, right? But the limit is actually c, right? And now c can be anything you want, except possibly 0. Okay, so this is an example that shows that you can't tell what the limit is. I mean, here's an example of something where you have one thing that's going to infinity, that's x, and then the second thing is going to 0, but you can't tell what the limit is. To tell what the limit is, you actually have to work with the specific function that you have. There's no general rule that says what the limit is going to equal. Okay, so that's why the second approach doesn't work. Okay, so neither of these things work. And in general, if you have infinity minus infinity, you don't know what the limit is, you have to do something else. If you have infinity times 0, you have to do something else. So what do we do to find the limit? Now this limit might still exist. In fact, it turns out that it does exist. So now let's actually talk about how to do it. So basically, the trick is to multiply and divide by the conjugate, the radical conjugate, right? So, okay, let's just rewrite what we're trying to evaluate. It's the limit as x goes to infinity of the square root of 81x squared plus x minus 9x. Right? Yeah. Okay. So let's multiply and divide this by the conjugate. So multiply. So this is all over 1, right? So the conjugate, the radical conjugate, is going to be the square root of 81x squared plus x plus 9x, and then the square root of 81x squared plus x plus 9x. Again, I'm just multiplying and dividing by the same thing, so I didn't change the function. So now let's multiply all this out. So this is going to equal the limit as x goes to infinity of, okay, you're going to have this. The bottom is just going to be the square root of 81x squared plus x, okay, plus 9x. And then on the top, I have this quantity minus this times this quantity plus that, right? So now I'm going to use the algebra effect that if you have a minus b times a plus b, this is equal to a squared minus b squared. That's just true by multiplying things out. It's called the difference of squares. Okay. So what you get when you multiply it out is you're going to get the square root of 81x squared plus x times the square root of 81x squared plus x. So that's just going to give you 81x squared plus x. And then I have a minus b squared, and my b is 9x. 9x in parentheses squared is 81x squared. And now I get some canceling because I see on the top I have an 81x squared and then a minus 81x squared. That's going to equal 0. So what do I have now? I have the limit as x goes to infinity of, so I have an x still on the top, right? There's this x term here. So I have x on the top, and then on the bottom, I have the square root of 81x squared plus x, and then plus 9x. Okay, now how do we find this limit? Well, you do the same as what we did before. I have, see, multiplying by the conjugate will not work because it will get me, if I did the conjugate, if I multiply top and bottom by the conjugate of this denominator, I'm probably going to end up back at the starting point. So here is where, when you have x going to infinity, you want to pull out the highest powers, right? So on the top, I just have x, that's going to stay where it is. Oops. That's going to stay as it is. On the bottom, I'm going to pull out an x squared from the square root. So should I show out the steps? Okay, I'll show out a few more steps. So x squared times 81 plus 1 over x, and then plus 9x. And then when I pull out the square root of x squared, right, remember I'm kind of skipping a step. I have a square root of a product. I can write this as the square root of x squared times the square root of 81 plus 1 over x. And then the square root of x squared, that's the absolute value of x. And in this case, x is going to infinity, so x is really positive, so it's just going to be x. So this is going to be the limit as x goes to infinity, x over x times square root of 81 plus 1 over x plus 9x. And now what can I do? I can factor out an x from the bottom, from the denominator. And that's going to give me x times, in parentheses, the square root of 81 plus 1 over x and plus 9. And now what can we do? I have a factor of x on the top and a factor of x on the bottom, so I can cancel those, right? And what I'm going to be left with is 1 on the top, and on the bottom I have square root of 81 plus 1 over x plus 9. And now we can evaluate the limit. And what do we get when you evaluate the limit? Well, the 1 over x is going to 0. So this limit, I'm ready to say what the answer is. It's 1 over the square root of 81 plus 9. And that's going to give me 1 over 9 plus 9 is 18. So the limit is 1 over 18. Okay. So a fairly complicated problem with lots of steps, but this is a fairly difficult limit because some of the natural approaches don't work, right? That's what I was explaining at the beginning. And then there's also a bunch of steps. But it's really not that many steps. I mean, the point is that you multiply and divide by the conjugate, right? That's what we did on this step, okay? And then you multiply it all out, and when you multiply it all out and simplify, you get this, right? That's kind of the next big step, is to get this. And then once you're here, you can just do it like we did before. Okay, now let's see what happens if you had the limit as x goes to minus infinity. So if I had the limit as x goes to minus infinity of the square root of 81 x squared plus x minus 9x, what happens? Well, if you multiply and divide by the conjugate, okay, which part of this changes if you look at it? What do you have to do differently since x is going to minus infinity? Right, if you look at the steps, you'll see that the only difference is in going from here to here. Because remember, we used the fact that the square root of x squared is the absolute value of x. When x is positive, this guy is x. When x is negative, it's negative x. So when x goes to minus infinity, I have to put a minus sign there. So let's see if I can change this, take this, and then move it. Okay. Oh, I don't want to do that. Copy. And now I'm just going to change this to minus infinity. What? Kidding me? I was able to do this before. Oh, I guess I just have to write it in. So x is going to minus infinity. And I have to have a minus sign here, right? Because the square root of x squared is negative x when x is negative. And now let's see what changes. Well, again, I can just factor out an x. So limit as x goes to minus infinity x over, if I factor out an x, I get a minus square root of 81 plus 1 over x plus 9. And now when I cancel out the x on the top and bottom, I have this. And now what happens? Well, I see this 1 over x is going to 0. So now I see that the denominator is approaching 0. Right? I have a 1 on the top, and then as x goes to minus infinity, the bottom is approaching 0. So I have this 1 over 0, and so what do I have to do? I have to look at whether this expression is positive or negative. Now when x is really negative, okay, the square root of 81 plus 1 over x, okay, so this 1 over x is negative, right? When x is really negative. So that means that 81 plus 1 over x is going to be 81 minus a really small amount. So that's going to be less than 81. It's going to be close to 81, but less than 81. And so when I do the square root of that, square root of 81 plus 1 over x, that's going to be less than 9. So in the denominator, I have this negative square root. That's always going to be a bit less than 9. And now when I add 9 to that, I'm going to get something that's slightly positive. Right? So the denominator approaches 0 but stays positive. And so the limit of this expression is going to equal positive infinity. Okay. So that's the answer. It's positive infinity. Okay, that's the example I wanted to illustrate. And I guess the key takeaway is when you have something like this, you have to multiply and divide by the conjugate and then proceed as usual. And just a recurring theme is we're going to see if you have infinity minus infinity, you have to do something else basically, and if you have infinity times 0, you have to do something else. You can't just say what the limit is once you get this. Okay, that's it.